Alright friends, so today we're going to be conducting a simple random sample, or learning how to conduct a simple random sample, also known as an SRS. So this entire unit is basically on sampling and taking good samples, how to create the most unbiased sample we possibly can, as well as running an experiment, and running good randomized experiments. So in our warm-up, we looked at a couple of bad sampling methods, or in your warm-up you looked at a couple of bad sampling methods. The first one was a voluntary response sample. And what a voluntary response sample is, just to kind of remind you, is a sample in which individuals can choose to be a part of the study or not. The issue with that is when you have a voluntary response sample, the people who choose are generally the people who are most passionate one way or another about whatever the topic is that is being explored. So you kind of just get the most extreme opinions and ideas being utilized. So when I talk about voluntary response, I kind of think about it as like Twitter. I consider Twitter one of the biggest voluntary response samples in the world, and that's because you're not going to write a post on Twitter unless you feel extreme one way or another, and so that kind of guides things towards being extreme, and that's kind of the voices that you hear. Same thing happens with voluntary response sample. Next one is a convenience sample, and that's when we just sample the easiest possible sample that we can get. The most common example we'll see from this is let's say that I want to take a sample of how much homework people did at night, and I ask the first 10 people who walk into my classroom. Well, that's a biased sample, right? There might be a reason why those individuals are the first people coming into my classroom, and that might affect the results of my study, may cause some lurking variables there. The one good sampling method is an SRS, or a simple random sample, and that's what we're going to be exploring in these notes. So in order to be considered a simple random sample, a true simple random sample, is number one, each individual has to have an equal chance of being chosen, and number two, each group from the population has to have the same chance of being chosen. So any group from the population of the same size, of a certain sample size, has to have an equal chance of being chosen. Now, if we don't meet these criteria, that doesn't mean that we have a biased or a bad sample. It's just in order to be considered specifically a simple random sample, both of these criteria must be met. Right? So there are going to be several ways that we can conduct simple random samples. We could pick individuals' names out of a hat. Key thing for that is you want to make sure that you're writing the names on equal sized pieces of paper, and you also want to make sure that you are mixing up the hat, or mixing up the names before you pick them out of the hat. We can toss a coin. I would make sure to mention that it's a fair coin. We can roll dice, again, fair dice. Or we could use a random number table, or we could use a graphing calculator. So we are gonna explore this unit, how to use your graphing calculator to randomly select numbers. So in scenario one, we have 2 random students are being selected to participate in a pep rally event from a sampling frame of 6 students. So 3 girls, 3 boys. Each student is given a number from 1 to 6, and a die is rolled until 2 unique numbers appear. Notice how I mentioned specifically that I need unique numbers. That's going to be something that's important in this unit when you're writing how you take your sample or how you randomize individuals, that you either say skip repeats, if you need to skip repeats. In this case, we can't choose the same person more than once, or state that we want 2 unique numbers. So again, a lot of what this unit is going to be is writing how to take a sample, or how you could take a sample. And you need to be careful, really considerate of what you are writing when you do this. So unique is a key word here, or skip repeats is a key concept that you need to be thinking about when you're taking your sample. And then the 2 students corresponding to the numbers will participate in our study. Is this a simple random sample? Well, does every individual have an equal chance of being chosen? Yeah, they all have a 1 in 6 chance, right? Does every possible sample size has an equal chance? So any combination of 2 individuals could be chosen, right? Lauren and Mike has the same chance as Lauren and Grace, has the same chance as Lauren and Lucas, has the same chance as Lauren and Hugh, has the same chance as Lauren and Jenny, etc., etc. Mike and Grace, Mike and Lucas, Mike and Hugh, and Mike and Jenny. Yeah, all of those have an equal chance of being chosen. Any group of 2 does. So it's a simple random sample. All right, 2 random students are being selected to participate in a pep rally event from a sampling frame of 6 students. So our sampling frame, again, is going to be the people that we're choosing from. To be fair, we want to make sure that 1 boy and 1 girl get selected, so students are divided into 2 groups by gender. Each student is given a number from 1 to 3. A die is rolled until 2 numbers from 1 to 3 appear. Notice how there's no longer 2 unique numbers, and that's because repeated numbers are okay here, because Lauren could be chosen and Lucas could be chosen, right? The 2 students corresponding to these numbers participate. Is this a simple random sample? All right, so we have our 2 groups. Does every individual have an equal chance of being chosen? Yes, each girl has a 1 in 3 chance of being chosen, and each boy has a 1 in 3 chance of being chosen. But does every possible sample of the same size have an equal chance of being chosen? Well, Lauren Lucas, Lauren Hugh, and Lauren Mike have an equal chance of being chosen, but what about Lauren and Jenny? Well, that's a group of 2 from my sampling frame, right? But there's no chance of that being the chosen one. So no, not every combination of 2 students can be chosen. Lucas and Hugh can't be together, right? So that means that this is not a simple random sample. This is still an acceptable way to sample. This is fine. This is random. This gets rid of bias, okay? But it is not a simple random sample. This is something called a stratified random sample. So let's conduct an SRS. I want to conduct a random survey of 4 students from the list below to see how many of them walk to school. The individuals we are selecting from called our sampling frame, right? We talked about that a couple of minutes ago. What we could do is put each person's name on a slip of paper and place them in a bag, give the bag a good shape, and then select 4 slips of paper. Now, I would recommend writing equal size pieces of paper or slips of paper, but the AP exam doesn't generally mark that as wrong. What they will mark you as wrong as if you use the hat procedure is giving the bag a good shake. We need to make sure that we're shaking up or mixing up those names before we select. Otherwise, the names we put in last are more likely to be chosen. We could also use a random number table. In this case, we would assign each individual in our sampling frame a number from 1 to 9. And we can go across the number table digit by digit, and the numbers that correspond to the numbers assigned to your sampling frame would be your number. So what would that look like? Well, you should have picked up a random number table from the front of class. If not, make sure you get one now. You can close your eyes and point your finger somewhere on the random number table. And from that point, you go across the random number table and select random digits. If you get a repeat, disregard and pick again. So, again, that last sentence, very, very important. We want to skip repeated numbers. You can just say skip repeated numbers if you are writing out how to do this sample. So we're all going to close our eyes and randomly point to the beginning of line 101. You did it. Good job. It's funny how that worked out. So we'll choose individual number 1. We'll choose individual number 9. We'll choose individual number 2. Whoops, I have another 2, so I need to skip that. So then we move on to individual number 3. And those will be our 4 individuals: Jessica, Joe, Bill, and Catherine. Can't choose Bill again, right? Our third technique is we can use our graphing calculator. So what will that look like? We'll get out your graphing calculators and pause this video, or pause this video and then get out your graphing calculator. Step one, we're going to assign each individual on our sampling frame a number, just like we did, so from 1 to 9. Then we can go to Math, which is right below your alpha, your green button. We'll scroll over using our right arrow to Probability. And we're going to select number 5. So you can either scroll down or just put number 5, rand_int. Well, inside rand_int, we're going to put the smallest number assigned. So for that, that would be 1. The largest number assigned for us, that would be 9. And the number of random numbers that we desire, in our case 4. Smallest number assigned, largest number assigned, and we want to select 4 individuals. Now, one thing where students run into a lot of trouble in this class and on the AP exam is not defining what your numbers in your calculator command mean. So it's okay to say use rand_int 1, 9, 4, but you need to explain what is the number 1, what is the number 9, and what is the number 4, with 1 being the smallest number assigned, 9 being the largest number assigned, and selecting 4 individuals. Now, if on your calculator you get, for example, 1, 3, 2, 2, you would use individual 1, you would use individual 3, and you would use individual 2, then press enter again. 4 new numbers should appear. You use the next unique number to be the 4th individual. So our calculators may have produced 4 random numbers compared to the individuals around us. So we might do in our class, not on the AP exam, but in our class we might seed our calculators. To do that, you type in whatever number I provide. Then you're going to press the STO button, which is right above on. Go to Math, PRB, number 1, and press enter. And it'll look like what you see on the screen. So let's use 153 in our calculator. So type in 153, select the STO button, which is above on, and go to Math, PRB, number 1, and hit enter. Then you can conduct your simple random sample. So you should have gotten Jessica, Anita, Rachel, and Joe. Right? Before we move on, you can go ahead and pop over to the next video to take a look at example number 2.